Hello everyone. I Atul Bansal, professor in the Department of Electronics and Communication, is going to take your course on signals and systems. Before we start the course, let us discuss why we are studying this course, what is the importance of this course, and what we are going to study in this course. So, first of all, what is signal? If we talk about the simplest definition of signal, we can say anything that conveys information is a signal. Like speech, what I am speaking and what you are listening to is a signal that is conveying the information. Then in medical field, you are very much aware of ECG signals, EEG signals, X-ray, MRI. These all are signals which tells us the information about our body. Then in military field or space application, we are aware of radar pulses, another example of signal. Then in day-to-day life, if we see stock price going up and down in a day or in a month or in a year, is an example of another kind of signal. Then any FM, AM channels which we are hearing conveys and transmits signals. Then the image or the video, like what you are looking at, is also a signal. They conveys you the information about the intensity of light at any point and then its variation with respect to time. So if you look at everything around you is some kind of signal that is conveying the information. Then next comes is what is system. If we again talk about the simple definition of system, it may be defined as a system is an entity that processes a set of input signals to yield another set of signals. So if you look around yourself, the different type of electronic gadgets which you are using, like in the home, if you talk about microwave ovens, refrigerators, washing machines, or in automobile industries these days, any latest car you talk about. Then in medical field, if you talk about these ECG machines, X-ray machines, CT scan machines, or even if you talk about your brain, what these things are doing, they are taking some kind of signals, processing them, interpreting them, and giving you some kind of another kind of signals. Like if you see your brain, what it is doing, it is hearing the speech what I am speaking of, and it is looking at this video. Then it is processing these two signals and conveying you the another type of information, that what I am speaking and what is written on and on this PPT slides. So this is what is the system. So if you understand this, any electronic gadget or day-to-day life, we deal with most of the times with signals and systems. So for an engineer, and more specifically an electronic engineer, it becomes very important to understand about signals and systems. That what is signal, what are the different type of signals, what are the systems, what are the different type of systems, how they behave, how we can analyze them before we design any electronic gadget, whether it is a household gadget, whether it is a commercial gadget, whether it is a military or space gadget. Any type of gadget we use that requires the knowledge of signals and system. So this course is a very fundamental course, basic course for an electronics engineer, because this will become a prerequisite for various other courses which you will be studying in your higher years, like communication, radar, satellite, image processing, microprocessor, control system, networks. Everywhere you will be dealing with some kind of signals or systems and their analysis and synthesis, or studying about their behavior. So understanding about these things in this course becomes very, very important. Now, next comes what we are going to study in this course. This whole course is divided into two modules, and each module consists of 3 chapters. So totally there are 6 chapters. The first chapter is on signals. That is, in this chapter, we are going to study about what is signal, how do we classify signals, how do we transform any signal, how do we analyze or synthesize any signals, what are the different properties and behaviors of different type of signals. Next is systems. Again, in this chapter, we are going to study about what is we mean by system, how do we classify system, how do we represent system, how do we analyze system, what are the behavior and properties of different type of systems. Once we understand about these basics of signals and systems, then we will move to the analysis of signals and systems. We will study the different tools which will be helpful in understanding and analyzing signals and systems. So the third chapter is on Fourier series. This chapter deals with the representation of signals into different types. So we will be studying the different forms of Fourier series. That is how we can represent the signals into different forms. And then we will study what type of information we get from those Fourier series. How do we analyze the signals from the Fourier series? But the Fourier series has one limitation. This type of series expansion is limited to periodic signals only. That is that type of signals which repeats itself and which exists from minus infinity to plus infinity. But in day-to-day life, the most of the time we deal with the signals which starts at some finite time. When we start analyzing, when we start working upon any system, so it has some starting point, that is t equal to 0. So that means that we will be dealing mainly with aperiodic signals. So this Fourier series cannot be applied over there. So that is the limitation of this. So to overcome this limitation, we study the another kind of transformation, that is Fourier transform. Now this is, as the name says, transform. So you understand the word transform means that we are transforming from one shape to another shape. Like you have the very famous movie Transformer. What it was? It was transforming from car to robots. Like so, transforming from one thing to another. So Fourier transform is a method, a mathematical way to transform the time domain signal to frequency domain signals. As it is very easy and important to analyze the signals in frequency domain as compared to time domain. Now, the Fourier transform removes the limitation of Fourier series, that it can be applied to periodic as well as aperiodic signals. So in this chapter, we are going to study about what is Fourier transform, how we obtain Fourier transform, what are the properties of Fourier transform, how we can apply Fourier transform to any system to study about its behavior and to analyze any system. Now, again, Fourier transform has its limitation, that there are lot many signals whose Fourier transform cannot be obtained. Then in that case, we study another type of transform in our next chapter, that is Laplace transform. In this chapter, we remove the limitation of Fourier transform. We can say that Fourier transform is a special form of Laplace transform. Laplace transform can be applied to those signals whose Fourier transform cannot be applied. So Laplace transform is applied to a continuous time domain signals. As well as Fourier transform we studied earlier in the next earlier chapter, it can be applied to the continuous time domain as well as to the discrete time domain. So we will be studying CTFT, that is continuous time Fourier transform, and DTFT, that is discrete time Fourier transform, in this Fourier transform chapter. Now Laplace transform is the transformation technique which can be applied only to the continuous time domain signals. So again, in this chapter, we will be studying what is Laplace transform, what are its properties, how we analyze any system using Laplace transform. Then lastly, we are going to study Z transform. Z transform is similar to Laplace transform, but the only difference is Z transform is applied to the discrete time domain signals. Now, discrete time domain signals and continuous time domain signals, what we mean by them? This thing we will be studying in signals, but first chapter, that is chapter 1. But just at this moment, you can understand that any signal which is continuous in time domain, that is, it is defined at every instant of time, is called continuous time domain signal. Whereas any signal which is defined at discrete instants of time is called as discrete time signals. So Z transform can be applied to discrete time domain signals. So again, we are going to study what is Z transform, how we apply it, what are its properties, and how we can analyze the systems using Z transform, that is discrete time system. So this is the whole syllabi divided into 6 chapters which we are going to study in this course. So if you look at this course, it is very systematic and flow wise. That means that you have to follow the proper order. That is, first we understand about signals, then systems, then the Fourier series, then it is having some limitation removed by Fourier transform, then it is removed by Laplace, and then Z. So it means you have to be regular in this course from the chapter number 1 to the last to understand it in better way. Next, so at the end, if we talk about what is the course outcome, at the end of the course, what you should expect. So at the end of the course, you should be able to classify signals into different types, whether periodic, even, odd, energy, and power. You should be able to apply transformation on independent variable or dependent variables. You should be able to understand the system properties, which may be linearity, causality, stability. You should be able to evaluate exponential and trigonometric Fourier series. You should be able to understand what is Fourier transform, its properties, and determine the Fourier transform of functions. You should be able to understand and apply Laplace transform, its properties, and determine Laplace transform of functions. You should appreciate Z transform, its properties, and determine Z transform of functions. So that is, at the end of the course, you should be able to achieve these 7 outcomes. Now, the books which you can refer in this course, as the 2 textbooks, you can refer a book by A. Anand Kumar, that is of Prentice Hall India Publishers, Systems on Signals and Systems, or a book by P. Ramakrishna Rao of Tata McGrail. Then you can refer some books like Book of Chen or book by OpenM. Other than this, there are a number of books available in the library or internet or in the market. You can refer any of the books. Right? Now, thank you. So this was the introduction about signals and systems. We will continue with this course in the next class. Thank you.